Hi, everybody. Okay, so we talked about ionic and metallic ion formation, I'm sorry, at the beginning. And now we're going to talk about naming those ionic compounds. So how do you name them when you see them uh, in a formula, right? So if you see a formula, how do you name it? Okay, so the first thing I want you guys to do is take a look at your notes. You're gonna have to skip a couple pages and find your reference tables. Okay, so this is a reference table of all the common charges for transition metals. You are going to be using transition metals in compounds, so you do need to kind of know where these common ionic charges are for each of those metals, just so that you have an idea of whether or not your math is going to be close. So you'll be able to use this reference table, no worries. Yeah, so go ahead and pause and copy down the missing charges because all the elements are there. You're just missing the charges from this one. And we're back. All right, so we're going to take a look at the next reference table that you guys need to know. This is the common polyatomic ion chart. Now, either the formula or the name is going to be missing for each of these. So polyatomic ions are ions that are made of more than one element, but they're treated as a unit. Now, there's only one positive polyatomic ion on your chart. It's the very first one. It's called ammonium. It's NH4+, so it's a nitrogen and 4 hydrogens. And then the rest of the ions are going to be listed in order of increasing charge with no particular order as far as like alphabetical or anything. So go ahead and pause the slide and fill in this reference table. And we're back. All right, so we're going to talk about oxyanion prefixes and suffixes. Now, oxyanions, if you're looking at your reference table for the polyatomic ions, are anything that has an oxygen bonded to it. So these are things like your ClO3, CO3s, CO4s. There's some CrO4s in there. So anything that has an oxygen in it, that's O. So check out your reference table that you just filled out in the last slide, not the last video. And do you see any patterns to the names? Okay, so awesome if you do, and it's totally okay if you didn't. It's a little bit hard to see the pattern because there's a few exceptions to the rule. So there's actually a set of rules for naming most of the oxyanions. The exceptions are already listed for you in your guided notes, but we're going to talk about them. Oops, right here. In the next slide. So this set of rules was made for chlorine-based oxyanions, but it applies to most of them. Knowing these rules will let you read a formula and write the name without needing your reference as often. It'll also come in handy when we talk about acids later because acids that have oxyanions in them are named based on that oxyanion name. So like you'll keep the prefix and the suffix changes based on what you started with. All right, so when you're naming most oxyanions, you'll follow this set of rules. If your compound has 4 oxygens, your name format is going to be the prefix per, the root of the word, and then the ending ate. So for example, ClO4 is perchlorate because chlorine is your base or your root that's bound to those oxygens. And we use per to mean the highest oxidation state because per actually means more than or extra. And then the ATE just means a high oxidation state. If you have 3 oxygens, you're going to use the root plus ATE, that's ClO3. We call that chlorate. And this just means high oxidation state, okay? If it has 2 oxygens, we're going to use the suffix ite. So ClO2 would be chlorite. ITE means it's a low oxidation state. And then if it has 1 oxygen, we're going to put the prefix hypo, which means less than. So think like hypoglycemic is low blood pressure or low blood sugar. Hypovolemic is low blood pressure. So hypo is a very common science term to mean something that's very low or below normal. So we're going to use hypo, the root, and then the suffix ite from the previous one there. So ClO is hypochlorite, and this just means that this particular chlorine oxyanion is in its lowest oxidation state. Okay, so it has the least number of oxygens on it. The exceptions to this rule are sulfur, chromium, and phosphorus. For sulfur, chromium, and phosphorus, any of their oxyanions, ATE means an O4 and ITE means an O3. Chromium is a little bit weird because chromium also has dichromate, dichromate, I believe is the correct word here. Yeah, dichromate Cr2O7 2-. And that's just because, again, chromium is one of those transition metals, and it can do some weird stuff using those D and F orbitals. And then the other set of exceptions are hydroxide, cyanide, and peroxide. So these used to be thought of as monatomic, and so these were named using monatomic endings. And in fact, cyanide doesn't have any oxygens in it at all. It just doesn't have the same naming conventions. So it's because it was originally thought to just be its own like element. They thought there was an element cyanide, and it's not. It's a carbon and a nitrogen put together. All right, so we're going to look at how to name a binary ionic compound. And I tried to record this once and do everything on the slide, and again, it did not record my annotations, so I'm actually re-recording this one for you guys. So I'm going to switch back and forth between this and the whiteboard. So let me just get this set up a little bit better. I'm going to hide my presenter view for a second, and then I'm going to just swap between the two sets of screens. And it's not going to let me do it. All right, I'm going to have to just share my whole screen. There we go. And bring up that whiteboard. Okay, magnesium oxide, MgO. First, write the name of your cation. That's magnesium. Then you're going to replace the ending of your anion with the IDE. So remember that these are always written cation and anion. Okay, cation always comes first and it's always named first. So our anion is oxygen. We're going to pull the YGEN off and we're going to add IDE. So it's now oxide, and then we're going to just put the whole thing together. Magnesium and oxide. Okay, don't capitalize it unless it's at the beginning of a sentence. You write it just like any other word. No special rules there except that, you know, it has to stay together. Okay, so I'm going to switch back to this PowerPoint. And I think I'm going to just pull it up on my screen because otherwise it's going to be a little bit chaotic. There we go. Okay, now I can reshare. And just the whole screen. There we go. Okay, and so now we have we're good. Now we have naming a polyatomic ionic compound. So I have a polyatomic anion as my first example and a polyatomic cation as my second example, so I can show you how the naming conventions work with it in either position. Okay. So step one, you're still going to identify and name your cation. Then you're going to identify and name the anion. The exception to this is if your anion is a polyatomic ion, you do not change that name. You leave it exactly as it is on your reference table. And then step three, you just follow all other naming rules. Okay, so we're going to practice. Whoop, oh no, what did I do? I pressed a button. I pressed a lot of buttons. Okay. Sorry, guys. There it is. So I'm going to just slide this over and we're going to practice. All right. So I'm working with limited space. I accidentally sat my pad down on my keyboard and it did all kinds of craziness. All right, so again, I've got magnesium. Why? Because it's just easier to keep using it. So Mg is magnesium. We're good there. CO3 is carbonate. So we're going to do step 2, carbonate. Okay, carbonate is a polyatomic ion, so I cannot change the ending. I cannot mess with it at all. And then I'm just going to put it together. Magnesium carbonate. Again, don't capitalize it unless it's at the beginning of a sentence. So let's take a look with the cation being our polyatomic anion. So NH4, we're going to identify that as ammonium. So we're going to write in ammonium. Okay. And then we're going to look at our anion. Our anion is Cl, that's chlorine. We're going to take off the INE, add that IDE, and then we're going to put it together, ammonium, and then chloride, IDE. Okay, and again, don't capitalize either word unless it's at the beginning of a sentence, and then you just capitalize that cation name. Okay, so far it seems like it's not too hard, right? It's just following a couple of simple naming rules. And it's really, that's all there is to it, but we're going to go ahead and look at one more example. And this is doing a compound, an ionic compound with a transition metal. So step 1, no matter what you're doing, follow all other naming rules. Step 2, identify the charge or the oxidation number of the metal cation. Step 3 is going to write that charge using Roman numerals directly after the cation name in parentheses, and then you'll just name the anion based on what kind of anion it is. And I'm going to show you what I mean by that. So we're going to slide this over and we're going to do our last set. This is Fe2O3, and I can't tell you what the name of it is yet because we haven't figured it out. Okay, so the first thing I notice is I don't have any polyatomic ions in this top one, which is great. So now we're going to identify the charge or oxidation number of our metal. And what we're going to do is we're actually going to reverse our crisscross that you would normally do to write the formula. So we're going to take our Fe and our O here, and we're going to crisscross those numbers. So Fe has a 3+ charge. And then, of course, O has a 2-, but that doesn't matter so much. We really just need to know what's the charge of this guy. All right, so now that we know that Fe is a 3+, I'm going to look up what Fe is on my periodic table, and I'm going to find out it's iron. So I'm going to write in iron, and I'm going to put in that 3 Roman numeral. Okay, you can write this in as I's using the keyboard. That's fine. It doesn't have to be formatted just like this. But you'll write it with the cation name, no spaces, parentheses, Roman numeral, end parentheses. Then you put a space because this should be treated as a unit. Okay. And then my anion is oxygen. So we're going to go oxygen. Take off that ending, hit IDE. Okay. So this is going to be iron 3 oxide. Okay. Now, the second example I have is CuCN2. CN is a polyatomic ion, right? That's cyanide. And I don't know what Cu is yet. We're still going to follow those same steps. So we're going to do our reverse crisscross with Cu and Cn. Okay. If there's nothing here, that's a 1. So this is a -1. This is a +2. I'm going to go to my periodic table and I'm going to find out what Cu is. Cu is copper. So this is going to be copper, parentheses 2. And Cn on my polyatomic chart is cyanide. It's a polyatomic ion, so I don't change it at all. So I'm just going to write in cyanide. Just like that. And that's really all there is to naming the 3 types of ionic compounds. normal binary, polyatomic ionic compound, and the transition metal ionic compounds. Okay. All right. I will see you guys in the next video when we talk about those properties that we just skipped over in your notes.